Oh, that is super small. Alright, orthogonal vectors have this definition. So vectors are orthogonal or perpendicular equal to 90 degrees when the dot product is equal to 0. We're going to translate or kind of transition a little bit away from We're going to think about vectors, but not in the context of your project. We're going to think about vectors in terms of work. So here's the equation for work. F times D. This will go right below it on the bottom flat. Yeah, for work. Do you guys know this equation? What does F represent? Force, vector, and do you know what D is? It's, distance, and in pre-calc or in physics we call it our displacement vector. How much you've displaced or moved something, or distance. Very good. Now, have you guys done this in the context of vectors? Oh, so we have a lawnmower. And we know that this angle here with the ground is 30. And then we also know that 30 pounds of force is being applied when we push this. There's a couple things we're going to need to figure out. The first thing I want you to do, we're going to end up figuring out the work done at the end, but we're going to look at the force vector first. How much force are you putting into this? You have a magnitude and you have an angle, right? If we put this in component form, because that's what the dot product's in, right? We'll have our force vector. So translate this to component form. Take a minute. What you think. All right, Carlos, tell me how you figured out this force vector.
I used the different method because it's a 30, 60, 90.
Oh, okay. So that's fine.
The side, the opposite of 30 degrees is half the hypotenuse, so that's 15.
Okay. So you got 15 for one of the sides. Did you get the other side?
Yeah, it's 26 if you round.
Okay. Probably a lot of you didn't do it Carlos's way, but the cool thing about Carlos's way is it'll work. Raise your hand if you did it this way. Okay. Carlos, what did you get for your answer? 25.98?
And 26.
Let's just say 26.0. Round to the nearest 10 so we get in the habit of that. And then our y vector you said was 15?
Yes, sir.
Great. You guys done this before? We've been doing a lot of this, right? All right, second part of this. That's the force vector. If we want to calculate work, though, what else do we need to know? This displacement or the distance that's being pushed. So Shannon, can you read part B?
If the vector was pushed 10 feet forward, displacement vector of 10, 0, how much work was done?
All right. So we know that our work is 26, our force vector, times our displacement vector. Now it tells us what our displacement vector is. It's 10, 0. But this is, you should get 260. Because 0 times 15 is just 0. Now this is going to sound real strange. The units it's in foot-pounds. And the reason it's in foot-pounds is you're pushing it 10 feet, and you're pushing it with a force of 30 pounds, right? Have you guys heard of the unit, the joules? Joules? Yeah, this could be converted to joules because a joule is equal to a foot-pound. Okay? We're going to leave it like this, though, foot-pounds. All right, part C. This is too easy if we just stay here. So Adriana, read part C. Can you read it a little bit louder? Right angle. We know this is 20 degrees. And we know that this length is 10, right? I'm going to leave it at that. I'm going to see if you guys can take it from there. That is not your displacement vector. You need to find the displacement vector based on that. Magnitude and angle. So talk to your team, see if you can figure this out. All right. Once you get 9.4 and 3.4, this should make sense. 9.4 is a little bit shorter than 10, 3.4 up. What's my final dot product? 295.4 foot-pounds. And this should even make more sense. Because not all of you have mowed the lawn, but you can imagine. Which one takes more work? Up the hill, right? Why does this take more work? Yeah, you're pushing it up. It takes more work, right? So this actually gives you a value of the work done for what you're working with. Summer.